This is a review of the probability pages 6 through 10. So for this first page, just read through the top part, look at the example. First one has with the die here and the possible outcomes, and it gives example of likely, and it's asking if it's likely to get a 1 every time, and of course no, has 6 sides. And then there's a problem number 2 down here with 16 marbles, shows the different colors like reds, blues, and greens, and asks about the different probabilities of getting those. So it says in problem 1, is it more likely, less likely, or as likely not to roll an even number? And you should know from the possible outcomes, right? 3 evens and then 3 odds. So it's just as likely. So you should say it's as likely. There's an even number of both odds and evens. So, and then in problem 2, how likely is it that you will select a purple marble? So as you see here, the different marbles are red, green, and blue. So getting a purple, of course, would be 0. There are none. There's no purple marbles. Okay, I'll do a few of these on the next page. First one, Jolene is playing basketball. She scored 11 baskets, and she took 15 free throws. So of the 15, she scored 11. What is the experimental probability that she will score a basket on her next free throw? So for this one, you can take the probability of 11 out of 15, and you can use a calculator to divide 11 by 15, and it'd be about 73%, or about 7 out of 10. Number 3, for the past 4 weeks, Micah has been recording the daily temperature. During that time, the high temperature has been greater than 45 on 20 out of 28 days. What is the experimental probability that the high temperature will be below 45 degrees on the 29th day? So the next day, right, of 20 of 28, that it was higher. So on the next date, it would be only an 8 in 28 chance. So it would be less likely. So number 5 down here, for the past 40 days, Naomi has been recording the number of customers at her restaurant between 10 a.m. and 11 a.m. During that hour, there have been fewer than 20 customers on 25 out of the 40 days. What is the experimental probability that there will be fewer than 20 customers on the 41st day? So if this pattern continued, right, it would still be a 20 out of 25 chance. And this is asking for both the decimal and the percentage. So you can put it into the calculator. 20 divided by 25 is 0.8. And you can put that as a percentage of 80%. And here comes the next page. Factory makes bicycles. Out of 300 bicycles, 2 were found to have defective brakes. What is the experimental probability that the next bike will have defective brakes? So it would be only 2 out of 300 chance. You can reduce that to 1 out of 150. And you can even put it also as a decimal or percentage, 1 divided by 150. And you'd get less than 1% chance, because you'd get a decimal of 0.006, repeating decimal, and it'd be a less than 1% chance. Predict how many bikes out of 2,100 would have defective brakes. And for this one, you can set up a proportion. So the original number is 2 out of 300. This one's asking out of 2,100. So for this one, you can set up the proportion of 2 over 300 equaling x over 2,100. You can do your cross multiplication, 300x, which is 300 times x, and then 2 times 2,100, which would give you 4,200. And then you would divide to solve for x by 300 on both sides. These would cancel. You get x equals 4,200 divided by 300, and you'd get approximately 14 that would have the defective brakes. And number 3, a factory makes ceramic bowls. Out of 200 bowls, 8 were chipped. So this is similar to the one with the defective brakes. What's the experimental probability that the next bowl will be made not be chipped? So 8 were chipped, so subtract that number from the 200 there, and it would be 192 out of 200. If you put that as a decimal or percentage by dividing 192 divided by 200, there's a 96% chance that the item will not be chipped. And then similar to the bike brake problem, how many out of 10,000 will be chipped? So there's a shortcut for this one. I'll show you. 192 out of 200. That's how many would not be chipped. This is asking how many will be chipped. So you'd put 8 over 200 here. And then they want to know how many out of 10,000. So again, you can set up a proportion. And I'll do that a little bit different way this time. If you divided 10,000 by 200, you'd get 50. So this way is dividing by 50. So this way would be multiplied by 50. So if you did 50 times 8, you'd get 400. So 400 out of 10,000 would be chipped. So it would be 400 would be chipped. Number 5, a manufacturer of electric switches has a goal of producing less than 1.5% defective switches. Out of the last 300, 23 were defective. What is the experimental probability that the next switch will be defective? So 23 out of 300 were defective. You can just divide for this one to get a decimal and then a percentage. 23 divided by 300, and you get 0.07, and then you get some 6s with repeating until another 7. So I'm going to round this up to 0.08. And if you put that as a percentage, it would come out to about 8%. And as you see, that's a much higher rate than 1.5. So the answer here would be no, because there was a 8% defective rate. They wanted less than 1.5. Hey, next one. Kathy played a game of darts. She threw 15 darts and hit the target 9 times. What is the experimental probability that Kathy will hit the target the next time she throws a dart? So 9 out of 15, right? 9 is favorable, the total number. And then like we've been doing on the previous ones, you can reduce this fraction, and or you can also put it as a percentage. If you did the reduced fraction or the original fraction of 3 divided by 5, you'd get 0.6 or 60%. That would be the accuracy rate. Number 3 has a chart, so she kept track of the colors of cars that passed her house. One afternoon, she collected her data in the table, so it shows how many of the different colors passed her house. What is the experimental probability that the next car will be silver? The number of favorable outcomes for this one would be 36, and then you would need to get the total by adding all the other numbers with that 36. So 12 plus 9 plus 32 plus 42 plus 36 plus 1, and you'd get 132. So 36 out of 132. And then what's the experimental probability that the next car to pass will be silver? So for this one, you can reduce the fraction and get it as a decimal and a percent. So 36 out of 132. You divided, you'd get about 0.27, which would be about 27%. And then the last page, it reviews the formula for experimental probability. And remember, these are all pretty much approximately equal to. And it gives an example here about someone batting. So this one says Ramon plays outfield in the last game. 15 were hit in his direction, and he caught 12 of them. What's the experimental probability that he will catch the next ball hit in his direction? So favorable events were 12. Total number of trials was 15. So you can put this as a fraction. 12 of 15 were favorable. Then you can divide. You'd get 0.8 or 80%.